proportional relationships. Our learning targets for today are I can graph an equation that represents a proportional relationship, and I can write an equation that represents a proportional relationship. Now looking at proportional relationships, so the word proportional means equivalent in size. So a relationship between two quantities will be proportional if the ratio between those two quantities is constant. Two things will be true about a graph that is proportional. The graph will be a straight line, and the graph will pass through the origin. Now, if I have a little coordinate plane here, a graph that is proportional will be a straight line, and it will go through the origin. Remember, the origin is my middle point of my coordinate plane, 0, 0. If a graph does not go through the origin, it will not be proportional. I can have proportional relationships that are positive or negative. If we have a table, we'll want to check for equivalent ratios. So in other words, in a proportional table, if we divide y by x for each ordered pair, the ratio will always be constant. Now looking at this sample problem, we have Hillary is looking for a gym to join. One gym offers a membership for $25 a month. Use the information to complete the following. We'll complete a table and a graph. So if we want to complete this table to show the relationship between the number of months at the gym and the total cost of the membership, we can use the months along with the price per month to find out the cost. So if I go to the gym for 0 months, they're going to charge me $0. I go to the gym for 1 month, that would be 25 times 1, which is $25. 2 months would be $25 times 2, which is $50, and so on and so forth. So 3 months would be 25 times 3, which is 75. 4 months would be 25 times 4, which is 100. And then if I go to the gym for X amounts, we don't know how many months I'm going to go, but I'm going to continue to go. That would be 25 times X, which is just 25X, where X could be any month number. It could be 10, it could be 20, it could be 30. What's the slope or rate of change shown in this table? Notice my months is my X, where my cost would be my Y, my dependent variable. I'm increasing each month, no matter what, by $25. Every month that I'm increasing is just 1. My ratio of y to x is 25 over 1, so my slope is 25. My table is proportional because I start at 0, 0, so the origin, and there's a constant ratio between my y value and my x value. Now looking at this in graph form, we can use my table to graph this line. So I would have 0, 0 as a coordinate point. If I go to the gym for 1 month, it costs me $25. 2 months cost me $50. 3 months cost me $75. 4 months cost me $100, and so on. Connecting my points, my graph would be a straight line that goes through the origin, making it proportional. So again, my slope is the same slope as in my table, which is 25. And then my graph is proportional because, again, it has that same constant rate of change and it goes through the origin. Now, proportional relationships can be represented by equations. So a proportional equation is written in the form y equals mx, where m represents my slope or my rate of change. X is my independent variable, which is the input in my equation, where y is my dependent variable, which is the output that I get from whatever my input was. Now looking at problem 1, I have a table that shows the cost of a certain number of pounds of apples. So my pounds would be x, my independent variable, and my cost would be y, my dependent variable, because the cost will depend on the amount of pounds that I purchase. I want to know what the slope or my rate of change is. In order to find the slope, I'll need to find the change in y, which is $5.52, because 1104 minus 552 is $5.52, and divide that by my change in x. So my change from 4 pounds to 8 pounds, which is 4 total pounds. $5.52 divided by 4 would give me a cost of $1.38 per pound. So my slope is $1.38. Is my table proportional, and how do we know? Well, I have a proportional relationship if my ratio of y to x is constant. So if I increase or decrease by the same exact thing every single time doesn't tell me if I'm proportional or not. Because notice here, I do increase by 552, for every 4 units every single time. This doesn't tell me if I'm proportional or not. My ratio of 552 divided by 4 should equal 1104 divided by 8 should equal 1656 divided by 12, and so on. If that ratio is not constant, then I don't have a proportional relationship. So this is yes, because all of these ratios is $1.38. If one of those ratios was different than the other, then I wouldn't have a proportional relationship. Now I can write an equation of the table. Equations are written as y equals mx, where m stands for my slope. So instead of m here, I'll have $1.38, because I know for every pound of apples that I'm increasing, I increase by $1.38. Now looking at this graph, we can find the slope. Remember, slope from a graph was my rise over my run. So if I pick, let's say, the origin and 3, 4 as my 2 points, I'm going up 4 spaces and over 3 spaces. So my slope would be 4/3. Is my graph proportional? Well, I know my graph's proportional because my graph is a straight line and it goes through the origin. And if I wanted to write an equation of the graph, remember, equations of proportional relationships are y equals mx. The m stands for my slope. I found slope was 4/3, so y equals 4/3 x. In today's lesson, we learned proportional relationships have a constant ratio between my x and y variables, and they start at the origin, 0, 0. That's a wrap on today's video. We'll see you in the next one.